Thank you. Okay, so when we're looking at puberty stages, certainly at Reading weren't the first people to explore this. And when we started the Medieval Adolescent Project, it was a kind of a throwaway thought that we might be able to look at puberty in these individuals. And I got this because I'm a bit of a devotee of Louise Scheuer and Sue Black's juvenile osteology series. If you haven't come across these books, I urge you to look at them. They're fantastic for juvenile osteology, and a lot of these images come from their books. So Louise Scheuer and Sue Black had suggested in the development of the pelvis that, interestingly, the onset of ossification occurs within 6 months of menarcheal date. So I thought, oh, I didn't know that, and maybe we can see if we can find the ossification of the iliac crest. So they were talking about the iliac crest. So I thought maybe just to have a look to see if we can find it, and that's pretty much where it all started. However, in 2005, Legg had already attempted to look at puberty in his adolescence. So they looked at the fusion of the elbow and the pelvis in skeletons from 11 to 17 years of age. He had 22 individuals. And these individuals were from Moundville, Alabama, so it was an American population. And he looked at the fusion of the ischium to suggest menarche. And when he was talking about onset of puberty, he really meant onset of menarche. And that's just a word of warning if you're reading some clinical texts. What people mean by onset of puberty is often different. If they're doing a menarche study, so the date of the first period for a girl, they might say that's onset of puberty, where others might be talking about the onset of the growth spurt and acceleration. So just check when they're talking about onset of puberty that you know what marker they're using to denote that. Legg didn't sex the individuals, but he suggested that menarche was occurring at about 14.5, so about 15 years, which is similar to the result we had for our medieval study in the UK. Jurek had also, in Homo, tried to define what adolescence should be in bioarchaeology, and stated that it should start at the eruption of all the permanent teeth and end with the fusion of the spheno-occipital synchondrosis, which is the base of the skull. So people had tried to explore adolescence in bioarchaeology. So if my, I might turn my video off just for a sec to help with the sound. Okay. So one of the other things that people have tried to look at in adolescence is the growth spurt itself that happens at puberty. And so you may be familiar with these kind of growth curves, and this is some data that I produced many years ago. And you have by about 10 to 16 along here, so 10 to 14, when you're starting to get the onset of puberty, you start to get a deviation. And these are two different populations rather than a single population. But this deviation is seen as them lagging behind, this red line lagging behind the adolescence with the blue line during puberty. So that this is where all of the growth disruptions are really starting to show, because they need great amount of nutrition and health in order to enter the puberty growth spurt. So this is where you're starting to see the deviations. I mean, so there is several scholars have looked at puberty growth spurt and growth profiles, and I'll try and remember to put one of the references up on the website for you. Carduso is one of the most recent people to look at this. But so people have attempted to look at puberty and adolescence and growth in this way. So what's going on when puberty starts is quite complicated. You can see from the diagram on the right here that there are lots of different hormones involved, and new hormones or lipids or chemical factors or amino acids, they're all being identified quite regularly. More and more chemical components of puberty are being identified pretty much every week. So it's very difficult to keep on top of what's going on. But basically, what's involved is the pituitary glands and the hypothalamus. So it all starts in the brain. The brain sends down signals that start hormone release throughout the body. There's two main stages of puberty. Endrarche, which is the adrenal glands starting to release hormones, And we don't see this. This is an invisible stage of puberty. This is when the sebaceous glands are stimulated by the hormones being released, and they start to produce sweat and oil into the skin, and so you start getting acne. So these are one of the signs that someone's entering puberty, start getting acne, and the first signs of body start to appear at this stage as well. But these are all soft tissue changes that we won't see. It's known as kind of the awakening, where all these hormone changes start to have an effect on the teenagers. Then true puberty is gonadarchy, where you start to get estrogen and testosterone released into the body, and you start getting hip growth and breast development for girls, and testes development for boys. So this is when puberty has started proper. The modern ages of onset for these are the invisible andrarchy between 6 to 8 years, and then gonarchy from 9 to 13 years. This is, as I said, true puberty. And once these two processes are underway, they're linked, but they can be independent, so you can get a delay in one without it affecting the other. Once these two processes are underway, you start to get the growth spurt, and that usually occurs between 12 and 13 years of age in adolescence, obviously girls slightly in advance of boys. Okay, so I'm just putting it up there, not for you to memorize it. I won't test you at the end, but just so that you can appreciate lots of the complicated and overlapping changes that are happening at the same time in puberty. So what we were really trying to do, and what clinicians have been doing, is mapping skeletal maturation onto periods of the growth spurt as a proxy for sexual maturation. Okay, so here we've got the two different lines. So you've got girls in red and boys in blue. So the duration of the puberty growth spurt for boys and girls is the same, but boys enter it later, and leave it later, but they take about the same amount of time to grow as the girls do. So it's a misconception often that boys take longer. They don't, they just enter a bit later. But you can see that you get a change from start to get this peak in growth. So this is hypothetical, I've just created this graph. So a peak in growth, let's say it's about 11, and then you have acceleration and PHV, and then they start to decline and you get deceleration and completion or cessation. So these are the features that we've been looking at on the skeleton through maturation to try and map this progress through the growth spurt. So the puberty method that we devised then, or particularly my PDRA Fiona Shapland had a lot to do with devising, was reading through the clinical literature and finding a lot of literature on particular maturation factors that are happening when kids are at a particular point of the growth spurt. Yes. So we use dental age because dental age is a lot less variable, it's a lot less affected by environmental factors. So you're more likely to get a most accurate stable age from the dental age, the true age of that individual. And then we look at the variations in maturation in the skeleton to look at when people are entering certain parts of the growth spurt. So there are 6 main phases. Well, one is kind of not a phase. So pre-puberty is when nothing's happening, everything's unfused, they're still pretty much a child, and skeletally they look like a non-adult. Then you get the onset of puberty, which is coinciding with the growth acceleration. So the puberty growth spurt is starting, and people they're starting to grow faster. Peak height velocity is when they reach the pinnacle of all of the growth that they're doing. And remember, it's not just the skeleton, it's all of their body systems are increasing. Musculature is increasing, their heart and their lungs are increasing, that brain is developing again. So all of these things are happening at the same time. Bone mass and lung bone length is all happening at the same time. And then once they've been through that peak, which lasts a number of months, then they start to decline. So we get then growth deceleration. And so these are the features, these are the stages of puberty that we have tried to map out using maturational stages. Okay. So I'm going to go through these different stages for you. And so this rather complex looking table now that we've developed basically has all the different phases. So from 0 to 6, so from pre-puberty to completion. And then you follow through for the different, these are the external changes that are happening. And then you follow through for canine. This is what the canine's doing at these stages. This is what the hamate is doing at these stages. The phalanges in the hand, aspects of the bone of the wrist, and then the ilium. And then this is the vertebral neck, cervical vertebra in the neck, the morphology changes through puberty. So all of these things have been tracked through the clinical literature and associated with particular parts of puberty. And we've been using those to see if we can do something similar in our skeletons. So it looks quite complicated. So what I've done is I've shaded in the kind of most crucial parts to consider when you're trying to do a stage or develop a stage. Things that are really happening are the bits that I've shaded in. So the canine root. So this was really first talked about by Churchcow, who in 1980 mapped tooth mineralization with the growth spurt. So he used Demerjian's scheme, and this is very similar to Moraes, Fanning and Hunt. So if you understand how to interpret these diagrams, then you're from Moraes, Fanning and Hunt, then you'll understand this. Basically, they looked at those aspects that I've highlighted in red of final development of the canine tooth. So from F, G, and H. So F is, I think the roots are half, then you have the initiation. So that usually coincides with the onset of puberty. G is acceleration, so they've started hitting growth spurt. And then H, you get complete, the tooth is complete, the apex is complete, and this is at PHV. So although the teeth survive very well, and it might give us a nice indicator of what's going on, it's only useful up to PHV. And then this was quite a surprising find from the clinical literature. And I have to confess, having studied non-adult children for so long, I don't ever notice that the hamate didn't have a hook until they were slightly older. So this was quite fun when this was discovered. So basically, there's as you enter the puberty growth spurt, the hamate develops its hook. It's a carpal bone in the wrist. And the clinical literature has kind of the hook, it's not developed at all, so it's underdeveloped. And then it starts to appear, becomes a little kind of nub of bone here. And then they have this kind of completion where you have this full curvature to the hook. It's a nice mature hook there. Fiona added in H.5 because she could see that there was a slight point between H and I where you get a little bit more of the development of the hook and almost starting to get a curve that we can see in dry bone that wasn't as obvious from looking at x-rays, which these have all been developed on hand x-rays where they could see the hook. So because we're looking at dry bone, we've got a little bit more detail to this. And so we put this down as acceleration and then PHV achieved. So peak height velocity is achieved once you start getting that curve. Okay, so we have Grave and Brown were the first people to really talk about lots of different features, but they particularly focused on the hamate. So again, like the tooth, it's only really good up to peak height velocity. You can see if somebody died during that time. So just have a look at these two hamates. I'm not going to do a poll or anything yet. I'm going to subject you to that. So you've got one on the left and one on the right. So if you're thinking about the one on the left, this one, what stage do you think you would score it? Do you think the hook's developed or developing? Okay, so I would score that as an I. And I'd score that as a, so this is complete. So this person has gone past, they're either at or they've gone past PHV. So you have the curvature of the hook there. So that's a nice complete, it's still quite a young individual. You can see it's quite smooth looking carpal bone. And then the one on the right, if you compare it to the one on the left, I would say it's slightly more developed than an H. So it would be an H.5, a middle one. So again, at PHV or sorry, at acceleration before PHV. You'll see this skeleton again, 471 is quite famous in our collection. Okay, so that's the carpal bone, so that's the hamate. And then another area that's been looked at quite a lot for this, the phalanges. So lots of different studies have included the phalanges in their research. I think they're quite interesting. I think there's more work to be done looking at the fusion of the phalanges. They're very similar to the way that the iliac crest fuses, a kind of similar process. So they are quite interesting, but they also do very intricate things that you can see them on X-ray, but we have a better chance of seeing dry bone as well. So the Grealish pile atlas, if you haven't come across it, is a maturation atlas that clinicians use to track growth of children and their development, and whether they fall behind or are on target for their normal development. And they use that as a kind of an indicator of if there any pathology, then they refer to it as and use a Grealish pile atlas as a kind of a marker for what the delay that they might be seeing. Quite a famous atlas. It's online. You can get hold of it online. So when you look at the distal phalanges of the second metacarpal specifically, they map this against the puberty growth spurt. However, we've looked at the phalanges. You can use any of the hand phalanges, and they all pretty much do the same thing. Particularly 2 to 5, so ignore the thumb, but 2 to 5, they do the same thing. They're usually the same level of development. So because these are quite small and very rarely excavated, you want to use as many as you can. So use the phalanges. So at acceleration, the epiphyses are the same width as the shaft. So if you have that little plate of bone that is the epiphysis for the phalanx, then put it up against the base of the phalanx and see if it's the same width. So in this case, it's the same width as the bone. Yeah. And then they become capped just as they're about to fuse. You start to get this little kind of hook forming. And you'll see this in any of the epiphyses as they start to fuse. They get this kind of little kind of curvature around at the edges. And this is capped. This is great, my favourite. So capping occurs at PHV in the clinical literature. Then when they start to fuse, so they're not fused, they're fusing. Fusing is also great. That's always gives you a nice kind of aging criteria. Fusing of the distal epiphyses has been associated with menarche in girls. So looking for and fusing is also useful. So, you know, any archaeologists out there, or when you're talking to any archaeologists, get them to, as always, concentrate on excavating the hands, and these little slithers of bone are the epiphyses. But at least if you can tell them there's a reason why we might be able to use it to look at puberty, then you might spark their interest enough for them to be more particular when they're excavating the hand. So those are the phalanges. And so this is our 471 adolescent again from the Reading collection, and you can see it's not laid out properly, so I was showing someone the hamate, so both hamates are together. So the hamate is at H.5, and then you have, there's the epiphysis for the distal, for the phalanx. So the actual scheme, the clinical scheme, is based on the distal phalanges, okay, but I'm saying you can use any of these phalanges. There's scope for study to see whether they really match up. I've done some work on Sudanese children and they match up as far as I can tell, but there's certainly worth a little study in looking at that. But in this case, I would say this is about the same length, and I haven't flipped it over, so you can't see whether it's capped, but it's the same length as the base there. But all of the distal phalanges are unfused. So that would put this individual at acceleration. So this, we think there's a boy, died just as he was entering the puberty growth spurt. So he still looked very much like a child, maybe slightly tall, but still would have had a childlike appearance when he died. Okay, so I hope that much is clear. Then you can look at the wrist and the elbow. So these are things that are fusing a bit later on in the growth spurt. So we concentrate on the proximal ulna, the capitulum of the humerus, kind of round bit there, and the distal radius, again from the clinical literature. I added the humerus as and a new stage, the maturation stage, in my 2017 paper, because I could see in our data set that there were a group of individuals who were kind of saying, well, they're at completion, but they weren't completely, they were in between deceleration and completion. So maturation was the next stage that we could add. The radius stays open for the longest period of time. I'm currently doing a little bit of research into, see this capping again? This is the distal radius. This is from Grealish Pile. And if you look at the atlas, there are, again, looking at some modern clinical girls, this seems to be matching up to menarche, but don't use it as a sign of that yet. I'm just saying that's a potential future research, looking at other areas of the skeleton that we can look at. So looking at these areas will help you go through maturation and the later stages, deceleration, maturation. And then we have the iliac crest. So this famous throwaway line from Scheuer and Black about the fact that it ossifies 6 months before menarche. And it ossifies during the deceleration period. So girls reach menarche after the peak growth. So they are physically mature. They are they've done most of the growth that they're going to do, apart from their pelvis continues to grow. Somebody asked me a question about that after the first session. So the pelvis can continue to grow in its breadth till you're about 30 years of age. So after deceleration, then they start menarche and the ossification. But if you can find the iliac crest, and you can see how thin it is, you do find them, but you have to look out for them. If you can find it and it's ossified, but it's not fused, you can then use that to pinpoint the age of menarche of your sample. But it's really rare. So for example, I think we had 600 individuals where we were quite sure we knew, or where we estimated a stage in our large sample. And I think it was 25 girls had an ossified iliac crest. So we are on the lookout for other areas of the skeleton, such as the phalanges and maybe the radius, so that we can add to our repertoire for pinpointing menarche, because it's such an interesting stage. Okay, so on our fusion scale, we've talked about the Risser scale, which is the scale that clinicians use to how much, when it starts to fuse, it starts fusing at one end and fuses all the way around, curves all the way around the iliac crest. So you can use that to describe the fusion of your iliac crest in more detail. And it can get you to different stages of the puberty growth spurt. But to be honest, most of the time it's just fusing. And if you've got a little bit of it fusing, then that's all you really need to make a decision that that girl would have been post-menarche. So menarche was achieved. And complete fusion is post-puberty. So that is the last thing to really happen. And that's when you've got completion of puberty. So non-union of the iliac crest is very broad. So if you find an innominate bone and the ilium is fused, there's no crest fusion, but you don't have the iliac crest epiphysis, you don't know whether the iliac crest had ossified, but it just wasn't excavated, or whether it hadn't ossified. So unfused things using iliac crest for the longest period of time. It's not very helpful. But generally, unfusion isn't particularly helpful. Fusing is great. Fusing really helps you pinpoint your stage on the puberty scale. Okay, so survival morphology, or CVM, is one that people find in the lab quite hard to identify. So I'll give you a bit of extra kind of coaching on what it actually looks like. But basically, as you go through the growth spurt, the morphology of your neck vertebra changes. It goes from being quite flat to being curved. So this is looking at one of the vertebrae from the front and then looking at the side, and you see how flat it is there. And then as you go through this growth spurt, it starts to curve. So Fiona took the quite famous, this is really, clinicians love this method because they can see it on X-ray, they use it all the time. They've used it on lots of different ancestry groups and they always say it's perfect, fits really well with puberty. I don't think the experience from osteology is the same. Sometimes if anything's going to be out, it's this. if you've got everything else in agreement, but the CVM is usually out. So there's again a bit more research to be done in looking at the how useful this really is, this method is for us as bioarchaeologists. But anyway, I digress. So you have all of these different stages that Fiona photographed from the skeleton to fit to the clinical diagrams that you normally have, but you can see these changes. It becomes more and more curved as you go through the different stages. And that was published in the 2014 paper for the CVM. So the method was devised on C3 and C4, but you can use C5 if you want to. Be any earlier, then they're slightly different morphology. C1 and C2 I would avoid. So you want to look at it from the side and you want to look at the vertebra from the front. So to show you, have to excuse my wiggly lines here, but these are 3 different stages of vertebral morphology from, this is a prepubescent child. So you've got very straight profile. When you look at the vertebra straight on, it's very straight. It becomes slightly more curved as you go through, and then it becomes the mature kind of quite curved. It's got kind of a almost squared off, but quite extended. So you've got the 3 different stages and some in between. And I think it's the detailed variety in between that gets people confused. But here again, this is quite a juvenile one before puberty's really started. It's quite from the sides, quite flat. And then you get this curvature as you get into an adult vertebra. Okay. So that can help you. As I say, it's a very popular clinical measure for puberty. And so it's worth us developing it. But I think with caution, it'll be interesting to see whether it's just population variation where it sometimes disagrees, or whether there's a consistent issue going on with CVM. Okay, so I've kind of mentioned throughout that there are 2 particular stages of puberty. So as I've said, I'm a paleopathologist at heart, so I'm very interested in the ones that will tell us something about the health of the individual. So we know peak height velocity is a very vulnerable stage, particularly for boys, and if you're going to be delayed, or if the infectious diseases or chronic conditions that you have are really going to kick in, then it's preventing you hitting peak height velocity or delay you reaching that period, because obviously you need good nutrition and good health to be growing at your fastest and your best, to put on not only length of your bones, but also all of the musculature and fat and tissue and organ growth that you need. Obviously requires good nutrition. So PHV is also referred to as transitional phase, and it's when you really start to see someone changing. So for boys, they get increased musculature and their voice breaks. This is when the voice breaking is happening. And for girls, they get increased breast size. So for society looking at an individual and maybe providing an identity for that individual, that is when you can see these changes occurring and when they're more visible. Someone has entered or becoming fully mature. So PHV, you can look at hook development on the hamate, changes in the neck shape, so CVM, and also fusing aspects of the wrist and this kind of the shape of the capping of the phalanges. And then menarche, so is the ossified iliac crest is the most reliable marker. So the ossified iliac crest is so good because there's nice research done in the 1940s where they had a group of girls who were delayed in their puberty. They had Turner's syndrome, which is a congenital condition, and they weren't, their pelvis wasn't developing and they weren't having their periods. And so they were given estrogen artificially, and within a few weeks of having estrogen, the iliac crest suddenly appeared, and 6 months after that, they had their first period. So it's been very closely related to menarche, which is why I think it's so reliable. But you know, equally there were mentions of the distal phalanges forming at that time as well, but they weren't concentrating on the phalanges. And when they decided, okay, this is what's happening, they didn't do any more research into it. It's quite frustrating that they found out what they needed to know. You and I, as bioarchaeologists, might want to know more. How exactly does it look? You know, what are the have we tried it on? For the clinicians, that was the answer, so they've moved on now. So as I say, there are a few indicators that can just look at menarche, which is probably one of the most interesting aspects. And this is in the deceleration phase for girls. But so more research to be done there, I think. So the method provides a series of locations that you can look at on the skeleton to try and plot where this individual might have been on the puberty scale. But the reality is we're using the growth spurt and changes, different aspects of the growth spurt as a proxy for sexual maturation. Okay. Some features don't always correspond. So the neck vertebra, certainly in our research from London material in particular, the cervical vertebra disagreed. When everything else agreed, the cervical vertebra disagreed. And this was Fiona Shapland who created the method, taking that scoring. So I don't think it's to do with observer error. I think it's just something wrong with the synchronicity of that change. However, others have reported that the Hamate is very difficult to score, and often that's out of kilter with everything else. So just be aware that, you know, it's still a new method and people are still trying it out in lots of different populations. And it's by no means perfect. And the more research we can do, the better it will become, more robust it will become. But like aging and sexing, this is all, you still have to weigh up how much do you think they might be in one particular stage or another. So you still have to use your judgment to produce a puberty stage. And again, like anything, if you're unsure, don't give it a puberty stage. Because if we start producing information on puberty on tiny samples where we're not sure, where we've added individuals who may or may not be male and we're not really sure what puberty stage is, but you know, we've got a feature, so let's do that. And we're not really helping answer any of the questions we may have in the past. So as a rule of thumb, I would say you'd need 3 features to agree. They should at least be available for you to look at, for you to be able to do this, and they should agree. So obviously one of the limitations of doing this method is you need almost a complete skeleton. One to age them, and particularly skeletally age them, and one to look at all of the different features to do a puberty assessment, which is why normally people who've published on this sample, on this method, have quite small sample sizes. But having said that, I think it's just as interesting to look at one individual and do an osteobiography and include their puberty assessment in that osteobiography, because you can say something about the way that they would have appeared to that society. And I think that's really interesting. So phalangeal capping and phalangeal fusion can help you refine your decision when you're trying to map the different phases. And as I said, anything that's fusing, that's the same for aging. If an epiphyte is fusing, you can really get a nice close age estimate. And just as in the same in the puberty assessment, if it's fusing, that usually helps you make a nice determination for a particular puberty stage. Okay, so the next slide is your homework. So let's recording now.